Alright folks, welcome back. In this video I'm going to show you how to take an equation like f of x or y equals, take the quadratic that it's in and put it in vertex form. If you need to, you can watch a video on completing the square because both of these methods are very similar. So let's go ahead and get started. I'm going to use the same quadratic equation that we used in the completing the square video, and this is the one that we used. We had basically f of x, or if you don't like saying f of x, you could use a y. But anyway, we have f of x equals x squared plus 5x minus 11. Now, the reason why the vertex form and the completing the square looks a lot alike is, well, basically they're almost one and the same, except in completing the square you're trying to get an answer for the x, but in the vertex form you're just trying to change the way that the quadratic looks. Okay, so needless to say, you're doing kind of the same things. And putting it in vertex form, you're still paying attention and giving a lot of attention to your x's. You're going to want to group them together. So basically, you still have this f of x equals the x squared plus 5x, but you're going to give it a lot of room, and just come over here and write minus 11, so that way you can actually see what I'm paying attention to. So I'm still really concentrating on this. Now, just like in completing the square, you know how we create a new number and we account for it on both sides? Well, we're going to do the same thing here, except this time we're going to account for it for the side that it's on for the number that we create. So basically it's like this. We are still going to have the f of x. We're not setting anything equal to 0. We still have f of x equals, and what we are going to do is basically open up a huge set of parentheses and put a square out here. Okay, now what we need to do next is basically put our x here. Okay, now we're done with that part. We've got our x right where we want it, because look, we still have x squared. Here's x being squared. We're good. Now this is where we're going to still create a new number. Okay, so we're going to take half of the number that's in front of the x, and notice that half of positive 5 is 5 halves, so we're going to write plus 5 halves. Now if you really look closely, this is the new number that we've created. We have all of a sudden added in a 5 halves quantity squared. So what we need to do is we need to account for that by writing negative 11, which is still there from the beginning of the problem, but we're going to need to take away this positive 5 halves that's being squared. Okay, now looking at this, you can see the similarities in completing the square, but we're not setting anything equal to 0 and solving for x. We're just changing the appearance of the quadratic. So this gives us basically the same thing that you see here, which I'm going to be a little bit lazy because this takes a while to sit here and type all this in. So we're going to take this quantity and write that much down again, but we're going to square this. So we're going to square the 5 halves. So this is going to be minus 25 over 4. Now the reason I get that is 5 squared is 25 and 2 squared is 4. Now if you're saying, hey, that's supposed to be positive, you're right, it is. It's positive 25 over positive 4, but on the outside it's being multiplied by this negative 1, so that's why the negative's there. So this gives us f of x equals the quantity of x plus 5 halves squared, well, quantity squared, minus, now I need a common denominator in these, and it's going to be 4, so I multiply the 11, which is 11 over 1, by 4 over 4, which gives me 44 over 4. And you can see that 44 divided by 4 is 11. And there's the minus sign that we see in front of it. So minus 25 over 4. Now, I need to just combine these two terms, and I have held up my end of the bargain. I've got everything that I need there, and I will be done with the vertex form of the quadratic. So parentheses, f of x equals x halves, x plus 5 halves. I'm getting better at using just a mouse. Quantity squared minus 69 over 4. Now, I told you that you can actually check this. You can work it out by hand and solve for the vertex, or you can use a little program for your TI-83. If you like to have some of the programs I have on my TI-83, I've got a file that you can download from my website. But to get it, you'll have to watch some of the other videos about the calculator on my YouTube account. Alright, anyway, what we're going to do is we're going to use a program in here that's called Vertex. And what this will do is this will give me the points of the vertex. So originally we had 1x squared. Okay, in case you were wondering where I'm getting these numbers from, I'll show you. From here, 1, and then the number b is the 5 right here. And the number c is the constant that we see, which is negative 11. And notice that I get the following. Now, looking at this, you're thinking, hey, you're wrong. No. These are the points of the vertex. So like if someone asked you to write the points of the vertex, you would solve this, just this one quantity here for x. And you would get basically x equals a negative 5 halves, because you're solving just for the x. And the y value, if you basically plug in not plug in 0, but actually solve this for the y, you'll notice that this is your y, which is a negative 69 over 4. So we end up getting our points here, and notice that it is the same thing as what's on the calculator. So anyway, this is the vertex form. I'll use my bright colors to box in my answer. This is the vertex form. And you can see now how we get the vertex from the vertex form. Whatever inside of here with the x, just take the opposite of it. And then whatever on the outside for the y, that's what you use there. So anyway, I hope this video was helpful. If you need more videos on this, you can always ask for a request, or I can direct you to Khan Academy, because they have a lot of great features on there, as far as like working problems and stuff. Alright, well guys, y'all have a great day, and I'll talk to y'all, I guess, tomorrow or another day.